Okay, great. So now we would like to have a much more inclusive, collaborative, talking about the 7 subjects that we've discussed today. So each subject has a leader for you, and what you'll do is you'll pick one of the 7 groups to go to. You can have an hour discussion and talk about different topics that mean the most to you in that group, and the leader will come back and report back out as far as what you guys discussed and have some interactive collaborations among all of you.
So I'm representing the AI and AI Alliance. We met out there, and we discussed a whole bunch of things. So it was a nice tour through some modern themes. So I'll just read them out. So we were first discussing compute. So there were autonomous cars like Eshed showed us yesterday in the 1990s. There was actually, I think, a self-driving car in the 80s from CMU called Albin. And the models, when compute has driven a lot of the progress. The next thing we were discussing was the AI Alliance. What are the goals, especially given the very complex landscape of machine learning companies, so OpenAI, Anthropic, Google, and of course, Facebook is a big player. Another thing that's, I think, less well known, I just saw this paper last night, is now there are large language models that are quantized to 1 bit per weight. So originally, each weight would be an 8-byte float. There are different float formats, so people use something called a bfloat format from Google. But 1 bit per weight is shockingly low. There are also some interesting experiments where you can take gradients when you're training these models and treat them as ternaries, so +1, -1, or 0. And models still seem to train pretty well. We had one of the members outside who looked up the paper to see how much loss in accuracy you get. So for a popular data set called CIFAR-10, for a 8-byte float model, it was, I think, 75, 78%, something like that. For a 1-bit model, it went down to only about 65%. If you had just asked me how much do you think it goes down to, I would have said, I don't know, 1%, 0.1%. And of course, this is not well understood. But these are very interesting phenomena, and they have huge implications for energy consumption, for inference latencies. So that was one thing we discussed quite a bit. And related to that, there's a question of power consumption and training. GPUs are very convenient. They have high throughput, but they are very energy inefficient. And like Jonathan always says, there are old HPC architectures that are extremely successful and very energy efficient compared to GPUs. So the question is, if more and more organizations are going to train large language models, should we be moving away to other known computer architectures? So I think these were the main highlights from the AI discussion.
Okay, so didn't get any feedback. However, I did meet with someone who had questions about using MOC resources for essentially what are social science projects. It was a board member of the Urban League in Boston, and they are interested in using MOC resources for their coding and for their data. And there were a number of things that he hadn't thought about that MOC can bring in terms of introduction. So for all of their public data, the Dataverse represents a very capable location for their data sets, both for their raw data and for their analysis. They work with Code for Boston, and that would be a source for data analysts creating the skills necessary to perform that function, but then serving as resources. And then the member universities of MOC Alliance can actually provide social scientists, people who, master candidates, maybe PhD candidates, who would use the questions that the Urban League is asking as their thesis topics. So anyway, it was a nice meeting, and But if any of you do have feedback how to interact with MOC Alliance, still open, jstumpf@bu.edu. Thank you.
Well, we just had a small talk, Rory, Mark, and myself. And I found another marriage. That's between the physical and the virtual, or the physical and the digital. Because research space is all about these notebooks and how to sort of organize your research project and the support for it. And that has a lot to do with samples and doing stuff, writing things in your notebook, but you no longer write into a research notebook, you're typing and you're having links to lots of things. But you may be running an experiment looking for mutations and having Illumina sort of sequence stuff and the like. Many things that you do in the physical now space has a correspondence of doing something also in the digital space, or uploading data to NERC, for example, the simple thing. So the idea is, the simple, easy, actionable idea is when you upload something to something gets uploaded to the storage, have a trigger that runs some script, which then talks to your notebook and says, oh, this is the data we just uploaded. Rather than, I think, how people normally do it now is by date and month and year, that's their index. No, you want to sort of put it right into which notebook it is. When you get a sample arrived and someone pays the bill, you can sort of tie together all these streams together, both the virtual and the physical. And I think there's some immediate actionable item is just have these triggers put in. I think that was the main point. Anything else to add? Okay. Oh, that was a lot, and most of the people have left. Adam is very excited. Adam Belay is very excited about the connection between his traces and Memento. There's been a lot of discussions about Memento at different levels, and it's clearly going to be an action item. I think we have to sort of write up a list and get all the interested parties and get together. I don't think this organization is exactly the right thing, but man, everybody talked about it. It was sort of the undercurrent theme, as far as I'm concerned, that came out of this 2 days.
Sorry, I really wanted to say this again, I forgot, is that when you're talking, I want you to not just summarize what the discussion, but also just the whole session that you had. Is there anything else, or what interactions here that, from an AI perspective? Do you think we're doing something friggin' useful here in some sense of the MOC Alliance, of delivering things for AI? What are we broken? What do we need to do? Or are we on a good trajectory?
GPUs. We need more GPUs. I think many people would love to do larger scale experiments, training, fine tuning, like this 1-bit idea that was published. And the major bottleneck today is just getting access to GPUs. I don't think storage is going to be a bottleneck. That's cheap and easy. There might be more. I just can't think of anything right now.
So I'm going to just comment on that. So I just had, it was really interesting, Dave Paulides, I don't know if he's still here, but he was talking about in 2 Sigma, I don't think it was, well, tell me if I should shut up, but he was talking about they have these GPUs and they're streaming large amounts of data, and it's actually the GPU turns out that it's actually I/O bottlenecked of getting these huge data sets, and the GPU sitting there idle because they can't feed the darn thing, because if it's streaming through these huge data sets. So, sorry, is that not the opposite of what you just said?
I don't know. So the fact is we have never actually done these experiments. I know IBM has trained large models on OpenShift AI, but we have very limited experience training large models. So that sounds very reasonable, but I mean, right now we don't even have the GPUs. We haven't even started anything.
Yeah, sorry. I just was saying, the difference is where the data is coming. Is it coming from some S3 bucket into segregated storage far away and then has to be deserialized and all that overhead to get it into the GPU, or is it already sitting on an SSD next to the big server or not, right? And that's a big difference.
As an example for what we're doing in the NERC now, we've generated all our data on the node, like 13 terabytes, sitting off of the NESI attached storage, and we're caching it onto the node. So look, sure, in the large, and probably for 2 Sigma, it matters a lot about that latency, but I have my data. We need GPUs to train the model on, right?
So this is my general thing I'm really curious about, is that I thought other people would know what the heck they were doing, in terms of feeding the GPUs, like, 'cause we haven't had access to them till very recently, and they're almost up, right? But how do we feed them? Like, what infrastructure? How can you, like, can they be to what degree is multiplexing possible, or is the 80 gigabytes or whatever of internal memory sufficient so that that's all you friggin' need? And it's like I've been asking those questions, and I don't know if I'm too stupid, but nobody's been able to tell me this, which is,
So people don't know, and one of the reasons they don't know is because it is ultimately application dependent, right? So some applications are going to need more memory, some applications are going to need less memory, but
we should know the averages. We should know, like, isn't anybody monitoring a cloud environment and telling me? Like, I had this conversation with Wayne, some researcher, though may nameless. I was asking them, what's their utilization of GPUs? And they said that they were 100% used, and then, what was it, 20, 15%? Yeah. So it's just,
And all I can tell you, people have been asking me to sell them GPUs for 4 years, and when I ask them what they want to do with them, 1 in 10 has an answer, right? And I can't sell them a solution unless I know what they want to do, because I don't know what bandwidth do you need, what storage, how much local memory, how much the thing. So I think the thing that David said yesterday, on some kind of benchmarking and some kind of comparison, fidelity of the model, big model, small model, big GPU. So I think it's not known. It's not that they're not telling you; they just don't know.
Well, this is like when something's so expensive. I mean, even the cheap things we have in operating systems, we measure the bejesus out of them, and we know how to use the thing, right? I mean, so is one of the biggest things, I'm asking this question, is one of the biggest things we can do is actually collect the telemetry and the information in order to be able to give these answers? Like, where's Heidi? Oh, there she is. I mean, Heidi, like, I just, like, is this a value that Red Hat needs for its platforms and 2 Sigma? I just don't, do we need to build this, or do you, like, the telemetry? No, we don't need to build it. Oh, good. So what's the answer?
Well, I just comment again, it depends very interestingly in the usage model, right? Like, I actually do think there's some room for some telemetry here, but remember, for many people, if you've got your data close to you on your node, or you're generating your data, as far as I'm concerned, yeah, to be honest, of course the GPU's largely underutilized while I'm interacting and just sort of sorting myself out. And then I might kick off a big batch train, and then it's going to be idle as I sort of play around with test inferences and do all that kind of stuff, because it's an interactive process for a while until it turns batch. Now, what we've noticed, so I have been, while we do it because I'm a systems guy, I have been running the NVIDIA tools to be keeping in the background, monitoring both the memory usage and the power usage of it. So if more broadly that were sort of being measured and gathered and archived, yeah, I think as a systems person, I could use that. But I think to the point that, do you think your user knows that? They've never been asked to think about it unless you've been doing it at scale, in which, yeah, that's a different.
So let me ask you AI guys another question that I'm really curious. So another thing that David said to me was that a whole bunch of your use on Google's cloud or whatever, you're actually using spot markets. I said, oh, really? There's a spot market for GPUs? He says, no, we can't. We do a lot of our stuff not actually using the GPUs, but just using the CPUs for AI. So, and all these libraries work equally well on GPU or CPU. not equally well. I meant they work, right? Can we shift from using GPU for some period of time then not using a GPU, or do we have to, like, is it just frozen? If it starts using a GPU, it's stuck on the GPU. Like, can I multiplex these to accelerate them? I'm just trying to figure out how we can provide service to people.
So let me just talk real quickly about what you got and what you can get. Let me talk about the configuration of the node that you have, the nodes that you have, and then you can, and I'll tell you about the capability of it. So in the nodes you have are 4-way NV-linked A100s. So they can aggregate the RAM of all 4 of the A100s, and so you can load a model up to, they're 40 gig A100s, so they're 160 gig, and run it across all those. The other thing that you have is a tool NVIDIA has called MIG, which is multi-instance GPU. Right, so you can cut them up to 7 smaller GPUs and cut the RAM up the same way. It happens to be in 7 equal slices. But from a management standpoint, from a cloud standpoint, you could sell all those instances or allow users to use all those instances as long as they fit within those, you know, 1/7 of the RAM. So, I mean, you guys know about this.
Sorry, this is just me still asking dumb questions because I don't understand. Like, so I think that when I asked you or somebody else about this a while back, it was like the application specifies what they need from the GPU in terms of the memory. So if I can present a 7th of the GPU, it's not like it'll run slower, but be able to use it. It either fits or doesn't fit for the allocation, not the actual usage, right? Yeah. So, and how do brilliant people figure out how much memory they need?
So the thing is, most people who are actually building a model, you have no idea how big of a model you need for a certain task. So if you give me some, let's say, vision data set, images and let's say classification, something straightforward, I don't know how many layers I need. I don't know how big those layers need to be, right? So to be very precise, if they're convolutional layers, I don't know how many filters I need. If they're transformers, I don't know what the sizes of my keys, values, and queries should be. So I might experiment a bit. When I experiment, I might do it on the GPU or on the CPU, because I just want to make sure the operations I'm defining are working. I can flow data through my neural net. Then I might train. I might go and look at my test accuracy, let's say. Say, okay, it's good, it's increasing. Let me try increasing my model size. Maybe by doubling everything, I'm making my numbers up, but if I double all the sizes in my neural net, that means
that's always what we do, is you double it.
Not necessarily, but you increase it. Let's see what happens to my test performance. So I can't start by saying I want a test accuracy of, let's say, 95%. And from that, I cannot back calculate how big of a network I need. Now, there are some with LLMs, there are these so-called scaling laws, empirical rules or plots that tell you, well, if you have so much compute, so much data, and so many parameters in your model, your test loss or test performance should get to this point. But generally, for most problems, you don't know that. So if you give me a large GPU, I might not use all of it. Again, it depends on my problem and how much data I have.
Yeah, I think what you're saying is your problem is that you don't have it, you don't know because you don't have it. you don't have any access, so you have no idea how big the model is. There are some rules of thumb that you can use on a number of nodes that create, model size, parameters, create equal, and NVIDIA can estimate that for you.
No, exactly, So even the scaling laws, you know how many parameters you roughly need, but they have those scaling laws because they took a lot of OpenAI's training data and literally plotted test performance versus number of parameters. But if you're starting from scratch on a new task, like the one that Jonathan and I are working on, is not text data, it's like memory traces. You have no idea, so you just have to do experiments.
So I think the point thing here is just having access, Oran, and as time goes on, people will finite tune down to what they need, but right now they just don't even know because you can't get your hands on one.
Exactly.
Well, sorry, maybe I'm missing something here, but if I understand how it works right now is that a person specifies an allocation, and if they are trying to tune. They'll start off with the wrong thing and it won't work or something. But the thing is, given that unless I partition with MIG, which they'll go and they'll have access to the whole thing, right? And they won't necessarily have an incentive or knowledge that they can use something smaller, or I'll know that we should partition these a certain amount. I'm trying to figure out how we build a system, just to state this bluntly, is that our incentive is not to maximize the sale of GPUs. Our incentive is to maximize the use of the infrastructure and maximize the amount of science done on the thing. And I'm sort of frustrated from a bunch of the conversations over the last while on trying to figure out how to deploy this stuff, how to integrate into OpenShift AI and how to integrate into OpenShift. It's not clear to me how we should be both characterizing this, having the system, what telemetry we should be collecting, scheduling the system, and then there's another aspect, is how we should be building the system so that we optimize the utilization of the infrastructure. I think this is just a very big, I've asked folks, I thought IBM Research would have figured more of this out, but my conversation with them is, yeah, that's a really good question. And I'm eager to actually have folks focus on that here, or use the information we collect. Because I don't think it's, Doug, I don't think it's the end users. The end users might be able to give you one data point, which is, I need less or I need more, right? But they're not going to be able to tell us the mix of capabilities we should provide, how we should bill for them to optimize the utilization, and even how we can context switch them. And actually, going back to the question, I don't think you answered it, is can, these tools, these libraries, can use either CPUs or GPUs. Can I switch between them? Can I just...
Yes, yeah.
Okay, so I can actually take away the GPU for some period of time and then...
No. He didn't say you can switch. He said he can switch. He can, in his code, go, I'm going to move to the GPU. I can move to the CPU. Right now, it's driven by the application's choice, not some layer below the application.
Yeah, you make the explicit choice. You say, do I want my model on the GPU or CPU? Do I want...
No, see, I want to be able to say,
Yeah, but-
GPUs are contented right now. Let me give the user feedback, or the library feedback, or OpenShift feedback, and have it switch to using CPU if GPUs aren't available.
So Aran, I think you're on the right track, but back up a little.
That's unusual.
So we can build virtualization layers to exploit that fact. But before you go there, I think you actually already have started to implement what is currently a viable approach to the problem, the pricing model. So why did I choose to allocate 3 of your nodes? I chose one node called CPU. I called another node GPU because I knew its cost model. And now I'm trying to use the one node to figure out when I've reached a non-interactive point that it's worthwhile me going and doing batch work on the GPU node. And if the VM allocation had been that I wasn't paying for that one while I was doing the exploration, I actually would have been forcing myself to recognize in my workflow when I was non-interactive and interactive. Now, a better model to that is to start gathering telemetry data and to start then figuring out, can we start to help identify these things and then potentially move them around? But I think these are iterative processes to get there.
Yeah, so, all right, I just first wanted to, part of my goal of this, of bugging you all with this is I was trying to understand if this really is an important problem that isn't, if Jonathan says, yeah, you've just done the right thing by exposing to me the information, I don't think most people are Jonathan. So it's actually, yeah, well, you get that. We can do that today. Yeah, no, I think I think that this is a really important question for us to focus on. And I think this is probably an important question for Red Hat in the platforms, and maybe even for Two Sigma and other companies, to understand how this should be presented and billed for, and et cetera. Okay, so John, when are we getting more GPUs? No, but seriously, do you have other things you want to say outside of the summary of the conversation? Okay. All right. Sorry, next group.
Let's move on to
Apologize.
Christy and the open cloud. Michael and the open cloud.
I'm actually going up there.
Michael did homework.
Artwork.
Artwork.
And I didn't do it. Okay. So I should note, Christy delegated this to me. We wrote you a haiku. We wrote you a haiku. Open standards free, facilitation is key, quantum play we need. And because we had ChatGPT do that, we actually had to fix it because it initially gave us a second line that had 8 syllables. This is what we fed ChatGPT. Basically, open standard interfaces are a great enabler. They allow people to move workloads. But facilitation is at least as important as that. And we can't write the drivers for the quantum computers if you don't get us some to play. You could tell our table had a lot of engineers at it. And then we said to Dolly, make us some artwork. So this is what Dolly came up with. We had to give it a couple of tries to get it to do the right thing. I think I had a 4th slide. Did I? Nope. Oh, yeah, I did. And for the summary that Oran was asking, I can take this off. I'm up here. The session summary of what Christy talked about earlier is essentially we finally have all the building blocks, which is something that we've been working towards for a long time. So that's it. Questions?
So I was disappointed by that group because it was all the open cloud people sitting together. And you guys asserting we have the right building blocks is not confidence building for me. I kind of wanted other people saying that wanted to deploy services saying, yeah, you guys all have the right building blocks.
We did too.
But yeah, no, I'm excited that I'm excited that we have a set of building blocks sufficient to start with. I'm not at all convinced that we don't have to have richer telemetry, especially that's feeding this stuff. That we don't have to science on how we're going to properly bill for stuff to maximize the utilization of the value we're providing. But I firmly agree. It's exciting to have a building block sufficient to allow this to grow in a self-sustained way. So thank you, guys. In fact, I guess one thing that was bizarre to me is I wasn't aware of a set of the things that had been built, like some of the stuff that Hakan talked about. You know, that now we can actually get this whole topology and we can expose that, because that, like, if the Open Cloud Testbed has that topology, then it knows there's a source of truth that all the different things can use, because right now we didn't have that, and we've been making it up. So, so I'm excited about a bunch of stuff that was built that I didn't even know about. So nice job, guys.
Thank you. So we had a very lively group. We also decided that we need more GPUs, right? So that's a theme here, I guess. No, I'm kidding. I'm kidding. To analyze all the data we want to collect. Really, really good group. Lots of people together. Interesting discussion. My feat of the day was that Eric, Thorsten, and I were sitting together in the end talking German. Next time we'll do this over a beer. But coming back to the topic, systems research, Jack, who unfortunately had to leave, was talking about federation, right? So really we have all these enclaves maybe, right? And so how can we federate them together to do bigger things and not have people, you know, using 5,000 logins? How do we get them privileges, non-privileges, all these kind of things? So that's really important topic to think about of the future. We didn't talk really much about hardware. We talked about principles and how we analyze and support systems research. The analysis, data analysis, so first of all, capturing data and analyzing data was another big topic. Needing standards, needing units. It's not always time series. Sometimes, John mentioned scatter plots and other other approaches to really understand the data you're collecting well and learn lessons from that, doing your analysis and so on. And how does this flow with modeling, right? So what we saw is, and maybe that's, you know, I would
like really like feedback from everyone else is also here in this group, we're a lot of systems people, but we don't have core modelers. And I apologize if I'm not ignoring someone. I don't do this on purpose, but it would be really interesting to get people who work on the model performance evaluation side together with us, because I think there would be a really nice interaction of, we have actual data, we can say how this is matched with models. We're just talking about predictions on GPU usage and all this stuff. Are there any models for that? Right? Have people thought about this? How does it match up? Well, you know, people say, you know, people have done, in the networking side, people have created models, control theory models for TCP, for example, right? Do they really reflect TCP, right? You measure it and you show it is or it doesn't, it does or it doesn't, right? So I think that's kind of what I mean by models. Large scale versus small scale, right? Some people say, well, we want small scale because we don't want all this noise that you get when you have a large scale testbed. Other people say, Roger had a really interesting argument. He says, I want large scale, I want to put proxies in so I can turn knobs and make increased delays, reduce bandwidth, do whatever kind of crazy things, and then see what that does with the performance of a large scale system like NERC, right? So that's another point. It's a little bit problematic, could be problematic, because what is if I'm the user and he throttles my bandwidth or something else, right? So we don't talk about it, okay. that's a good approach. Coming back to the data, it's also sharing data, right? We need standards, how and what's it called, provenance, if we want to share data, so others can use the data in easy fashion. Oh yeah, I think Heidi had a great idea, and I pushed this even a little bit further. You said in the olden days, people would come together and bring their routers and do interop testing, right? And if you want to test federation and maybe other interoperability between test beds, why don't we do this? Why doesn't everyone bring their test bed in a box or something like this, and we have what do we have? An interop test, right? I'm not allowed to say hackathon, actually. Oh, I did just say it. So some kind of event where people come together and test that. And I thought this is where ESI could be super cool, because we take, I don't know, I'm just saying it for the sake of argument, we take 100 servers out of NERC, ESI, 10 go to Cloud Lab, 10 go to Chameleon, 10 go to Fabric, 10 go to NERC and whatever, and we do interop testing, right? Perfect, right? So we could, maybe perfect, but we could do some nice side on that stuff. So that's a thought I really like, because you could bring communities together for federation testing and things like that. Am I missing something important? Okay, good, thank you. Or any questions?
I'm just going to jump in. In all seriousness, if anyone, just send me a paragraph or two. Tell me why you need GPUs. I'm serious. Tell me why you're hindered today. Tell me what you're going to do if I give you a ton of GPUs and what benefit it brings, okay? If you give me that, because I am working on trying to acquire 192 GPUs, okay? And help me get them for you.
Tala, are you writing this paragraph? Okay, thank you. My student.
Okay, Milson and
Just remember, it's not binding. We won't force you to actually do what you say. We just want good justifications. So while we're on this, one thing that came up today with talking to one of the folks is they were saying, you know, we could get people to opt in to providing their data for systems research and stuff. And I guess that one of at least my beliefs, and I'm curious Wayne's perspective on this, is that I think we can be kind of we have to preserve student confidentiality. We have certain things we have to do to respect privacy, but in a sense, I don't think there's a problem in terms of making things, putting in a user-level agreement to say, you know, your data will be collected for research purposes, and your information about how you use the computers and what you're doing, you know, not that we'll have file names, not that everything won't be anonymized, but I don't think we need to have people opt in. I think that if they're using, you know, MOC Alliance NERC, they are not just users, but they're also subjects of study. Is there any problem in that from your perspective outside of whatever telemetry doesn't end up crippling the performance of the system? Like,
I think a lot of it depends on where you live and what country you're in. And so, you know, Europe has a lot more restrictions than we do.
no, it doesn't depend on that. Because what we heard from the lawyers, as long as they assert that the regulations don't apply to them, even if they're lying, it's fine.
The hand waving that Michael just did is probably what concerns me around that. So, yeah. So you know, I think generally telemetry is valuable, and being able to provide that in a very de-identified, anonymized way for research, I think is a great idea. I think a lot of it has to do with compliance, and the compliance landscape is constantly changing, and we're having a hard enough time just on the enterprise side keeping track of it, or the research administration side keeping track of it, and having your research comply to it. So just saying, yeah, we should just do it no matter what, I think is a big reach, and we just need to tread carefully because the landscape will continue to change.
Okay, thanks.
All right. So Milson and I were tasked with the user outreach and facilitation discussions, and he and I made up 2/3 of our team, which really wasn't surprising, right? Because most of our target audience aren't here today, right? You know, one of our jobs is to help people with what we call facilitation, and Oran suggested I talk a little bit about facilitation and what our potential end users might find frustrating. And so I find our job is kind of like computational lubricant, right? Or to talk to the end users and talk science, and then take those requirements and convert them to IT needs. You know, most of the people who are here who are doing science on the system are mostly systems researchers, right? And you guys are willing to learn the APIs and learn how to use OpenStack and OpenShift. But sort of the commodity scientist who might consume our resources is they have problems looking for solutions, not problems looking for Legos to build solutions. And so with you guys in the room who are people developing solutions looking for problems, you know, the facilitation actually happens in the reverse direction. So, you know, as you're developing something, I would encourage you to reach out to Milson and myself to talk about what you're developing so we can help figure out what science use cases they map to. And so when we're thinking about building out shared services, we really need to think about, you know, the person doing, you know, computational biology, genomics, or CFD, and they're not going to want to build something. They're going to want to consume something. And when you look across our member universities and look at what cloud services are popular today, it's not EC2 and load balancers and elastic IPs. It's Parallel Cluster, right? It's SageMaker, it's Google Colab, and it's simple storage services, right? S3. And we definitely have the components to build those solutions. You know, in that regard, you know, one of the things that I'm really excited about is OpenShift AI, right? I think OpenShift AI provides a lot of the capabilities that they get on these commercial platform, but also sort of, you know, puts our best foot forward, right? Our most compelling use case, in addition to GPUs, right, and real-time access to GPUs, is this kind of fuzzy metric, which I go back to, which is science per dollar, right? And that's really the big use case here is, you know, we can do the same things cheaper, but we need those shared services first. So Milson and I have been talking a lot about sort of education and short courses to try to help users come over that divide when going from traditional research computing systems to cloud computing, right? You know, most cases where people are first exposed to research computing is either their laptop or desktop, but it's probably their bare metal HPC system provided by their campus. And there they learn interactive, procedural, stateful batch workloads, right? And if we just give them a box of Legos, we're asking them to go from that to declarative, stateless, right, containerized applications. And so we've developed a list of courses and topics where we want to introduce those topics to our scientists And we do think some domains would benefit by being exposed to, Terraform or Ansible or some of these, declarative automation tools. But at the end of the day, the vast majority of our potential end users are looking for solutions, right? And so as you develop things, please reach out to Milson and I, because we definitely have the most contact with new potential users who want to be onboarded to MOC and NERC resources. Thank you. Comments, Oran?
I guess there's a couple of things that, I mean, just in talking to sort of industry partners, I had several conversations with some folks actually at Red Hat, and they said, well, this is really cool what you're talking about, these sounds, can you come to KubeCon? And I said, nope. And they said, can you, will you kind of participate in open source kind of community to work on these things? I said, no. There's this separation of, as a faculty member, as a faculty member, I won't do that. I'm trying to do my systems research. Faculty members are trying to get papers. Their students want to graduate, and they want to get their papers. In a way, the same thing you're talking about of people just wanting to get their shit done. We have, so we can have needs and problems and even solutions and stuff, but we don't necessarily want to create that sort, but it's not necessarily, we're not remunerated to work to iterate on a patch with an upstream community until that upstream community has that. I think that what we do have is kind of partnership with Red Hat, and we'd like it to be a partnership with other companies that can come and work with you guys, I think, to hear the problems that people are having. They can iterate with us as systems researchers to kind of develop, at least in our case, prototype solutions to certain things. And we also have a team of engineers here who actually can work on helping transition when there's a community in upstream. I think this is one of the, I think the facility is, like you said, is lubricant, but not just for the users to IT, but the IT, but actually in that whole cycle. And I think we've done something very unique with the Red Hat Collaboratory, where, especially with what Heidi's put in place around this stuff, that's enabled a richer interaction. But I'm still, this is where I guess my head is. I think you guys can bring more of the problems. I think we can offer you to state the problems, but also you understanding the resources we have in terms of engineers and in terms of systems researchers and the kinds of systems research that goes on to help identify the problems. Maybe, we have hammers and we want nails. So part of the things we can come to you and say, yeah, we have this hammer, do you have a nail? But it's also, I think, I'd like you guys to expose more to us what the nails are. Mm-hmm. Hopefully motivate us to do research to invent hammers for those nails, and then kind of closing the loop with industry and saying, hey, not only do I have this problem, but here I have this cool solution that's a prototype, trying to figure out how we build a process to actually get things accepted.
Yeah, definitely. And what I will say is also, as the solution builders, leverage Milson and I, right? Tell me about the solution you're building, and I can tell you what science use cases that could potentially map to. I'm a computational chemist by training, but for 20 years I worked as a hired gun while I was faculty in many different areas. So I speak almost every science domain that has, popular open source software. So, if you have someone who has a science problem and you're not able to connect to them and convert those to requirements, bring me into the loop. I'm happy to talk to them and take their needs and convert those to, Kubernetes, OpenStack, storage, whatever requirements. That's where we are there to help, right? Both directions, not only helping the users figure out how to use it, but helping the solution builders figure out what needs to be built to help our users. Thank you.
Okay. Now we can finish up with Jonathan and Danny, please.
You hand it over like a knife, right?
So Danny, did we decide that you'd give the quick overview of how the discussion went?
Yep,
Right?
okay. So in our discussion group, we have people there from Johnson's class. They are TAs from CS210, and they were sharing about their experience helping students figure out how to ramp up using Jupyter containers and help students register and debug their username issues, things like that. And we also have Red Hat engineer from OpenShift. He's working on education. He's very interested in our OPE use case. So we have some feature requests from professors and TAs, such as we want to improve our debugging experience in containers. We want to have more concrete error message when students facing problems when they are launching their container Jupyter notebooks. That's one thing. And we also illustrate some issues we are having with our current class. Our class on the Jupyter notebooks, that is all the classes are sharing the same namespace, that is default namespace, Rose notebook. This is really hard for accounting for classes for billing purpose. So that's the other issue. And Johnson also want to have SSH ports for his class to directly use their local VS Code to connect to the remote containers. The other issue that are required by OS courses is virtualization. They want to have full access to OS stack in order to have to let students have full experience of kernel. Other than that, I think overall feedbacks are very positive. No students are complaining about why their container is not working and not running, why their works disappears. So, yeah, any add-on?
Yeah, the only one I would add to that is something that came out of it was the consistency of the environment. So containerization is really helpful because it says that the bits that we're presenting to a student is stable from student to student, course to course, or sorry, semester to semester. But the other thing is the behavior of the container being consistent. So for instance, the TFs from my class pointed out that, yeah, you know, it's super important that we had configured the instance of OpenShift to turn off address space randomization, because we actually present material where they have to, in a discussion, look at virtual memory addresses. We had to go through the process of understanding on the given OpenShift deployment which of these features were critical to the user experience. And so further automating that, and also the question of what that means then every time we do an upgrade to OpenShift, right? Because that's going to imply understanding good mechanisms for any given course's requirement for consistency. And then, at least I was very excited to find out that the virtualization support is already in the product, and that for at least my class, like, it's a simple, when we upgrade, I'll be able to try it out. So I guess the big thing that we really wanted to do, of course, was have faculty here to sell them on using it, but we'll have to do that separately, I guess.
Wow. Is that it? Iran? Then why don't we set up with your closing remarks, Iran?
I don't know about the rest of you, but I'm exhausted. So, first of all, I'd like to go back. It's like, as it says up in letters on the thing, is we finally have the building blocks. I'm just, thank you, Christy. It's just like, it's perfect. It's up there. This is really first workshop where I think we really do have the building blocks to where we actually, I don't know how much money we have in the bank right now, but we sent out our first bills. And I don't know why Jonathan didn't get his. He probably just hasn't read his email yet. But we actually have revenue coming in, charging for the computers, or the use of the NERC environment. You know, there's a lot of holes in it. It's like, I don't like the fact, I built the revenue model, but even so, we did it at the NERC level because that was a clear thing. I'd like to have it at the ESI level to the NERC level. Each layer should be charged for. We have to now build the right infrastructure to meter it at the Lenovo level and actually send the right charges to there. But I think economics is fundamental to a cloud. Building an economic model for charging, and that's been an adventure in a university environment to do this in a way that I don't go to jail, which has really been, which I think we've now had. And Wayne and
He's setting me up.
and Nancy and John Goodhue, thank you, because I know that was an incredible amount of work, and you guys had to deal with the lawyers and not me, so thank you. I'm very excited about sort of each of those pieces that came in place, and I'm also extremely excited that we now are finally collecting the telemetry that we've been sort of promising since the day the project started. So these components are really coming together now. That's incredibly cool. And parts I didn't even know about, like that we actually now have something that can collect the entire inventory of machines and how things are networked together so that as a user or as a platform on top of the base thing, you can actually do a mapping and say, oh, this node is next to this node. This is the allocation I want in order to do the thing I'm trying to build. So the AI parts I still am very confused about, but that's probably because we're only in our inception of doing it. I think the use case is important, and I'm just worried. I mean, John, you got to get some GPUs, but I don't know if anybody's mentioned that. But I think that those components are kind of coming in place, and I think the AI Alliance is a really neat use case. And one thing I wanted to emphasize that was kind of the kickoff announcement from Hugh Brock is that we've built a lot of this technology, or we built pieces together with Red Hat, including some that we created from scratch, all the infrastructure that could be integrated together for a university in a way universities need it, where you have PIs, requesting allocations, having students and associating them with institutions, and then so all the mechanisms that we need to make this available for academia, as well as we're OpenShift, OpenStack, OpenShift AI, and then ESI, which is again using a lot of those components, but working with Red Hat engineers and our own folks to actually get that part together. And what's amazing is Red Hat is now committed to us that they're going to be with us doing this in a way that's economical, which is huge, because till now it's been Hugh begging hat in hand for money, or not for money, for licenses, so we didn't know if this was economically viable from, next year or the year after. We sort of believed we had a very strong partnership and that everything would be fine, but it's hard to convince, I don't know if, none of us have had any experience in academia of using products from companies and then them quadrupling the price or giving us from zero to a very large price a year later, right? So I think that there was concern about that, and just, it's not that I didn't trust Red Hat, but having that as a commitment from Red Hat is massive, and further the fact that it's just for NERC, it's just for us, which what it means is that there's this incentive if other universities see what we're doing, that everybody will join us. Like, we want this to be a partnership. We want this to be open to universities joining us, because if creating a critical mass, and I think we now have this incredible incentive. So first of all, thank you, Hugh. This is incredible. I guess that, so there's AI, the marriage of data and compute. This is, we sort of had a series of things talked about there that really excite me. Till now, we've replicated a bunch of what I think are the core capabilities that people need, and I think we're useful. I think that there's incredible opportunity to do something that no cloud does today by actually having deeper understanding of the relationship between things, the association, that marriage between data and compute. And it's not just a it's not just a high-level idea, it's actually realizable. I mean, the things that Uli's been talking about, the things that Mark was talking about, who just left, I guess, and you know, how Larry introduced that. This, to me, is where I think systems researchers, we have this opportunity to think about of doing totally unique and novel things. It took a lot of work to get to the point where we're reproducing what the public cloud does. Admittedly, not perfectly, but you know, we have core capabilities that are useful, but now what I'm really excited about is having, every time people use these services, them improving in some fashion through the cooperative caching, through the understanding of workflows and integrating that to scheduling, through the memoization. These are incredibly powerful notions, and we all know these things go on in cloud services in the public cloud, but they're done, in a sense, improving their service, and who knows how that's actually monetized. Here, I mean, we should be explicit about this. This is what we're doing. You come to our cloud, you're contributing your usage to improving our service, to get more science done on a common platform. So, you know, I'm sort of thrilled about what's come together. We've got the core components, and thank you, everybody, that participating. I think that every year till now, part of this has been about selling the potential. Of course, it's still that to some extent, but I think it's gone beyond that. It's like this, I think you've given us lots of food for thought on where we go. I mean, the notion of a data commons, to me, is really profound, figuring out how we actually move forward on that. What are other things that people want us to take back as feedback from this event? Okay. Tara says you all want to go home and I should shut up.